Hello everyone. I hope everyone is fine amidst this COVID crisis. We have started op-amp chapter and we have discussed the characteristics of op-amp and also few terms, important terms. Today we will see about CMRR. This is known as common mode rejection ratio. I hope my screen is visible. Okay. So suppose I am applying V2 voltage as input voltage in terminal 2, that is the inverting terminal, and V3 I am applying at non-inverting terminal. Okay, so the output voltage of the op-amp will be then V0 is equal to AD into V3 minus V2, where AD is the gain for the difference signal, that is V3 minus V2, which I can write as also VD. So if suppose V2 is equal to V3, suppose if V2 is equal to V3, then what we get, V0 is equal to 0. But in practice this is not the case, because the output, this output depends not only on the difference of the signals, that is on VD, but also upon some average level. So how do we calculate that average level of the signal? We also can calculate average level by just simply writing the average of the signals. This is called common mode signal. So VC is equal to the average. Just add the signals by 2 gives you the common mode signal. Okay. So we'll consider both the things, the difference of the signals as well as the average of the signals. Now, due to a lack in the perfect circuit symmetry, this V0 is equal to AD VD plus AC VC. Now what is AC and VC? VC we already have seen that VC is equal to V2 plus V3 by 2, which is called common mode signal, and this AC is the common voltage gain for the common mode signal. Okay, this is the voltage gain for this common mode signal. So in ideal case, what we know is that AD tends to be 0 and AC is equal to 0. This is for ideal case. Okay, in ideal case, these are the things that happens in ideal case. So a figure of merit for this differential amplifier is defined as the ratio between the differential gain and the common mode gain, which is called the CMRR. So CMRR is actually the ratio between the differential gain and the common mode gain. I hope I'm able to clear this section. So CMRR can be expressed in decibels, and it is written in this format: CMRR in dB. That is, the formula for that is 20 log 10 AD by AC. You will get sums with this formula. So just I'll practice few sums with you all. So this is actually CMRR, and higher the value of CMRR, you'll have better is the performance. Okay. So I hope this section is quite clear to everyone. If you have any queries, drop in your questions in the chat box, or you can also write to me. Okay, stay safe until our next class. Thank you all.